What would happen if we moved a Jovian moon to Mars? Why are black holes spitting out those jets? What's the best case scenario for Europa Clipper's search for life? And in Q&A Plus, how are we searching for sun-like stars? All this and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are, across my channel, question pops in your brain. Just write it down. I'll gather them up and I'll answer them here. All right, let's get into the questions. Ademnon's couch. What would be the long-term consequences of taking a large moon from Saturn or Jupiter and adding mass to Mars? Orbital, gravitational? People always wonder about this. Like, could we fix Mars? Right? Could we add things to Mars to make it better? And the problem is that there's not a lot of stuff that you could throw at Mars to make a planet that is the kind of size that you would want for interesting things to really happen. So, could you add Ganymede to Mars? Sure. Ganymede is smaller than Mars, less massive than Mars. Right now, the mass of Mars is 10% the mass of the Earth. And so maybe you could get Mars, if you fed it all of the Jovian moons, all of the Saturnian moons, maybe you could get it to 20% the mass of Earth, which would be more massive. Now you would cause untold havoc as you were slamming moon after moon into Mars. At a certain point, you would be liquefying its surface. It would be just lava, right? You'd be sending up giant plumes of material. The place would be uninhabitable for many human lifetimes, millions of years before it cooled down to the point that you could actually walk on its surface again. So those would be the long-term consequences. You would make the place like untouchable for as long as human beings have been around. I'm pulling numbers out of my head right now, but I don't know how long you would make the place uninhabitable if you crashed a 3,000 kilometer moon into Mars, but it would be bad. Right? It would be kind of like what happened when Thera crashed into Earth and formed the moon. It was a very bad day for many days. So, I think that if we want to make Mars a better place, like practically make it a better, like if you don't care about Mars, like you just want to I want to wreck Mars, then there's a lot of stuff you could do. You could take the entire asteroid belt and feed it into Mars. You could take all of the moons of the solar system. You can start bringing in Kuiper Belt objects. You could make a planet that is as big as Earth if you just kept going. But it would, it would not make for a place that was very habitable for a very long time. So, the kinds of changes that people are proposing to make Mars more habitable are a lot more gentle. Like, let's put a satellite in between Mars and the sun that blocks the solar wind so that the natural gases that are exiting Mars can build up and warm the planet. Let's then layer in some hardy cyanobacteria and other life forms that might be able to continue to thicken the environment. You get to the certain point that the ice caps will melt and then you'll have oceans and lakes and stuff on Mars again. Let's figure out other ways to thicken the atmosphere, maybe put in chlorofluorocarbons that can put global warming onto the Martian atmosphere. Those are the kinds of ideas that would get us a more usable Mars than just bombarding it into oblivion. John Divita, when a space probe uses a planetary slingshot, what portion of the assist comes from the planet's mass, the planet's axial rotation, and the planet's revolution around the sun? So I don't know what the percentages are, but I will explain how gravitational assists work, and then you can kind of take your answer from this, which is that, we know that spacecraft can get a speed boost when they go out past various planets in the solar system. And you can understand, this kind of makes sense that you've got the spacecraft that's approaching a planet. The planet's got a gravity well, and the spacecraft falls down into the gravity well, flies past the planet, and then it sort of climbs back out of the gravity well. And you would think that those two things cancel out, that the spacecraft would, the amount of time it spends going down balances out the amount like going down a hill and coming back up the other side of a hill. So how do spacecraft get a speed boost? And it comes from not the gravity of the planet. It comes from the orbital speed of the planet going around the sun. And so while you've got your spacecraft that's approaching, say, Jupiter, Jupiter is starting to pull on the spacecraft and it raises the orbit. So it's kind of like someone who's standing at the top of a mountain with a rope and they're pulling you up to the top of the mountain. And Then, yes, you've got the speed up as you fall into the gravity well, you've got the slowdown as you fall out of the gravity well, but you've gained that speed. You've climbed up to a different orbit now that you're going around the planet, and that gives you the additional kick. Now, there's a few other tricks you can use. When you're at the closest point of going around the planet, you can fire your thrusters, and that will give you an additional kick. It's called the Oberth maneuver. And then also, they will often use these planetary slingshots as a way to change the direction of the spacecraft. And so let's say that you want to go into a very different orbit. Well, you can come in at the planet in a certain direction, go around the planet, and then that will kick you out in a new direction that is better for the orbit that you're looking for. And the really cool thing about gravitational slingshots is they go backwards as well. You can use a gravitational slingshot to slow your spacecraft down. So you can use it to speed you up. But also, if you go the opposite direction, then essentially the planet is slowing you down to its orbit. And often these have been used to be able to get down to some of the inner planets like Venus and Mercury. And theoretically, you could just keep doing gravitational slingshots around, say, Mercury and eventually crash into the sun just by slowing your orbit down time and time again. Although it means you're speeding it up when you... Anyway, orbital mechanics are complicated. Trevor, my understanding is that the Europa Clipper won't be able to detect life itself, just whether life is possible. What specifically would be the best case scenario outcomes of this mission? So yeah, Europa Clipper is going to Europa, and this is considered one of the most interesting places to search for life in the solar system. But the problem, of course, is that you've got tens of kilometers of ice and then a ocean of liquid water underneath that. And the ocean is the interesting part. That's where you're going to have potentially geothermal vents at the bottom of the ocean that are putting various food for bacteria into the water, that you could have a thriving ecosystem. European space whales, and yet it's all trapped under tens of kilometers of ice, and we just don't know. So like, what is Europa Clipper going to do? Well, it's going to scan the surface of Europa, and there's a lot of really interesting features. Like, we know that it's being resurfaced. And so the question is, what is this process? Why is parts of Europa very young? You know, is it like cracks in the ocean where water is welling up and spreading out and smoothing out the surface of Europa? What are these weird dark patches on the surface of Europa? Is this organic material mixed in with the ice? We don't know. But the big question that the Europa Clipper is going to help answer is, like, how thick is the ice? Is it one monolithic slab of ice that is tens of kilometers thick that surrounds this liquid ocean? Or is it cracked and porous, and are there pockets of water very close to the surface? We know with Enceladus that there are geysers that are blasting water from inside Enceladus out into space. Is that happening on Europa too? There are hints that there are geysers on Europa, but none have been conclusively found at this point. And so when Europa Clipper does its scans, it should detect the presence of those geysers. And so we'll get the locations of geysers, we'll get sort of an understanding of what's under the ice, and it could be that we will find really interesting places. There'll be pockets of warm water that are just under the surface of the ice. We're just reporting on a story on Universe Today about how, you know, one of the things that Europa Clipper could do is measure the temperature of the surface of Europa and detect places where there are these warm pockets of water, briny water, like salty water, that's just under the surface of the ice. And that these are the places where maybe there could be geysers, cryovolcanism happening on the surface of Europa. So really, it's this just a way to understand Europa better. The very best case scenario, I guess, would be that they detected geysers and that they were able to measure various chemicals in the geysers, like hydrogen gas, various organic molecules in those geysers. That would be the same kinds of discoveries that have been made at Enceladus with the Cassini spacecraft. And then if I was going to be like really ambitious, you could imagine sort of closer to the end of the mission when they're in the YOLO phase with Europa Clipper, then maybe they try and fly one right through one of these plumes and see what they can detect as they're getting really close to the plumes. And then that sets the stage for us knowing, where should we send a lander? Where should we send a probe that could melt down into Europa to try and access some of this under ice water? And it could be just a few hundred meters underneath the surface of Europa is a place where there could be some water. And if there's some water, and if it's warmer, and if it's salty, then there could be life in there as well. So Europa Clipper is going to help us figure out where to look.
It's time to shout out all the new $5 patrons and above. Timmy Sycama, Tim Gleason, Brody Berg, Jay Cross, Barnabas Heidig, CQGC Phil, Alan Kanemoto, Starchface, John Frolworth, and Piotr Kwadzinski. Join the club at patreon.com/universetoday.
Steve Babarik, when I see a picture of a black hole, it shows everything being sucked into it and something needs spit out. What is it spitting out? Yeah, the thought is like black holes pull in everything. How can there be stuff coming out of black holes? And yet you look at the illustrations and you see this giant accretion disk around the black hole, and you see these jets coming off of the black hole. How's that possible? Well, so black holes spin, and as they spin, they torque up space-time around them. And they have this magnetic field that can form around the black hole. And that magnetic field interacts with the accretion disk. And these black holes are spinning fast. Like, they are spinning at the maximum speed that is allowed by relativity. Like, they're spinning at 60+% the speed of light. Imagine that, right? This object that is a few kilometers across that is spinning at 60% the speed of light. And then this magnetic field is churning up this area in this accretion disk around the black hole. And it creates these funnels that go out from the poles of the black hole that channel gas and dust out into space. And this happens at the small level. And so this material is not getting into the black hole. It's in the disk that's around the black hole that the magnetic fields are picking up and channeling outward. And then it is traveling out into space at relativistic speeds, close to the speed of light, off for tens of light years, hundreds of light years on the stellar scale. But this also happens on the biggest black holes. So the ones that have millions of times the mass of the sun, they also spin at close to the speed of light with enormous magnetic fields and these accretion disks. And then they produce these jets that go for tens of thousands, millions of light years off into space. And they're like these beams that can impact other galaxies. And so one of the really interesting pieces of research right now is, what is the effect of these black hole jets as they travel through space? And so if you're in a galaxy that is just, happily minding your own business, and then one of these beams from a black hole hits you, then this is going to cause star formation in your galaxy. This is going to cause enormous amounts of material to be falling into the galaxy, starting to compress clouds of gas into additional stars. That this is going to set off a wave of star formation in your galaxy. And so it could be that it's very good that actually being hit by one of these death beams was the best thing that ever happened to you. But also, it probably increases the radiation in the environment. And maybe it makes you use up your reserves of gas and dust too quickly. And then this material can also fall back down on the galaxy. So you've got the jets going out, it's being accelerated, but then the gravity pulls it back in, and it showers back down onto the galaxy. So this is a field of active research. And, we're seeing, we're reporting on this all the time, on these kinds of, how these jets, change the nature of the galaxy that the black hole's inside of, but also how this can actually cause issues with the galaxies that are around them. Ahmad Canrang, can you explain what a meteoroid is, what a comet is, and what the difference is? They're all stuff in space that you've got rocks and you've got ice. And so anything that is moving through space that is mostly made of rock is a meteoroid. Like, size sort of comes into it. Like, at a certain point, they stop being meteoroids and they start being asteroids. While comets are a mix of rocky material and icy material, and some organic compounds and other volatiles. But even that isn't very good distinction, because you can have comets that have small amounts of ice. You can have asteroids that behave very much like comets. So it's all kind of a blur. And then when these things strike the atmosphere, either a comet or a meteoroid or an asteroid, they become a meteor. And so then you've got this flaming line going across the sky. typically they burn up. But if they survive, then they reach the ground and then they become a meteorite. And that's where you can go and pick one up. So meteoroid when it's in space, meteor when it's flying through the atmosphere, and meteorite when it lands on the ground. And that you can have different amounts of dirt, ice, and other volatiles. And so often, like with a comet, it's more about the source. So while asteroids, meteoroids, they come from the asteroid belt and other parts in the inner solar system, comets come from the icy outer region of the solar system. Santiago, Kaderian, do you use Kelvin in Canada also? I thought you were centigrade guys. Yeah, so we are Celsius. We never use Kelvin, but Kelvin is the scientific method of measuring temperature. And so I switch into, when we are reporting on various temperatures, often we report them in Kelvin, which is easier for a person who grew up understanding Celsius because they're the same units, just offset by 273 degrees. I feel bad for the people who learned in Fahrenheit and then have to convert into Kelvin. But I am bilingual, imperial and metric. I understand how big a mile is. I understand how big a kilometer is. I understand how big an inch is. I do not understand Fahrenheit. I just don't. So you can tell me it's 70 degrees Fahrenheit and I would be like, that's cold? That's hot? I don't know. What does that mean? And my wife finally is starting to speak Celsius. She's American, right? So she'd be like, oh, what's the temperature outside? I'm like, oh, it's 10 degrees. And she'd be like, what is it in Fahrenheit? I'm like, I don't know. Google? Ask Google. So yeah, that's the one that I don't understand.
Did you know that you can get the same video but with no ads and get a bonus question over on Patreon completely for free? We call that Q&A Plus. And this week's bonus question, how are astronomers searching for sun-like stars? I'll put a link in the show notes so you can go watch that right now. All right, those are all the questions that we had for this episode. Thank you everyone who put your questions into the YouTube comments, everybody who joined us for the live show when it happened several months ago. Now I'm going to talk about another upcoming astronomical event. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Bray Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Balick, Cy Nelson, David Gilton, and David Matz, Evan Pro, Greg Feely, Hudson Moore, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Marcel Smits, Michael Purcell, Modzo, Nick Borges, Nick Solari, Paul Robach, Renkaidu, Robeck, Stun Sargent, Stephen Fowler Munley, Vlad Chiplin, and Wolfgang Klotz, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So this time I'm going to give you a little more advanced notice than I did earlier this week. And this is on September the 7th. There's going to be a total lunar eclipse. And unfortunately for me, it's going to be only visible from the other side of the Earth. And so I'm not going to be able to see this total lunar eclipse in Canada, but it's going to be really well positioned for anyone who lives on the east side of Africa through Central Asia to Southeast Asia to the west side of Australia. And so if you live kind of any part of that area, then you'll have a chance at seeing this total lunar eclipse. And of course, a total lunar eclipse is caused when the shadow of the Earth passes onto the moon. And in the beginning, you're just getting the shadow of the Earth passing onto the moon. It starts to take chunks and chunks away from the moon. And then eventually the entire shadow covers the moon. And then you get the refracted light that comes through the Earth's atmospheres, which is red. Essentially, it's the sunsets of the entire world are illuminating the moon, and it turns it this really cool red color. And that is a total lunar eclipse. And they take about 3 hours to happen. And they're easily my favorite astronomical event that you can watch at a predictable time, because you don't need any eye protection. You can watch it from anywhere. As long as you're in that hemisphere, you'll be able to see the lunar eclipse. You don't have to get away to darkened skies that even in a light polluted city, you can watch a total lunar eclipse. You just need to know that it's happening and you can go and watch it. Of course, people take great pictures of it and video, and it's such a great time. So if you live in that area, Eastern Africa, Central Asia, India, China, Southeast Asia, Western Australia, really all of Australia, you'll be able to see this eclipse. So give it a shot and let me know how it goes. All right, we'll see you next time.